Alright, so we're going to be talking about logarithms. Now, Algebra 2 uses logarithms to help add instead of multiply. The algebra formulas here make it easy to find an equivalence. The logarithm of a product, quotient, power, base, and the log of 1. What we're going to be focusing on is converting the way Mr. Massey did it as opposed to the way Ms. Nocera did it. And hopefully that'll clear up some questions that we have. So let's start off with the equivalence. Okay, so we know that logarithms help us solve problems that are represented graphically by the variable, such as x, being as an exponent. So, for example, 2 to the 5th, write it a little bit bigger here, 2 to the 5th equals, we'll call this y. Okay, and that can be represented still with variables. So we have 2 to the x equals y. Now, if we wanted to rewrite this in a way that would show it as a logarithmic function, we could easily do that with the following formula. Okay, we'd have log base 2 of our answer, which is y, equals x. Now, it's important to note that there's parentheses around this y, so it's not part of the base. Okay. So, now that that's out of the way, that's kind of how we did the swoop. If you'll remember that, we started here, log 2, so we just took the base, we took the base of the exponent, log 2, and then we swooped around here. We swooped from 2 to the y, which is the reason why the y is right there, and then we came back and the x is our answer. So that was kind of the swoop method in between Mr. Massey and Ms. Nocera's thinking. Now, I'm going to go ahead and write all the logarithmic rules, and you can take a screenshot of this in just a second. So again, we have our basic formula. If this is e to the x equals y, log, using the swoop, log e of y equals x. So log e of y equals x. Okay, that's one property. Now, remember, log of a product, let's say we have log 7 of 5 plus log 7 of 10. Okay, that's going to equal the product of these two, since the log bases are the same. So that's going to equal log 7 is 50, because we just multiplied 5 times 10 and combined the two terms. Log of a quotient, dividing, which involves subtraction. So if we had log 3 of 5 minus log 3 of 2, that's actually log 3 of 5 halves. Log of a power, say we had log 2 of x squared, that would actually be 2 log equals 2 log 2x. So you just move the exponent down to in front of the log. Okay, so also it's important to note that the natural log of 1 equals 0, and also that the log of a 1 is 0. So those are your logarithmic functions in Algebra 2 that you'll need to know for the test tomorrow.